Yes, yes, friends, there is a question on the board. A particle of mass m is moving on circular path of constant radius r, such that its centripetal force, centripetal acceleration is changing with time as AC equal to k square r t square, where k is constant. Prove that power delivered to the particle by the force acting on it is P equal to mk square r square t. Actually, centripetal force, concept of centripetal force is that है भाई कि when body moves circle path with constant speed, then there is acceleration towards center, and force which acts at right angle does not do any work. If no work done, no power. But here, centripetal acceleration is changing with time. At every time, it is changing, not constant throughout. Means it is not a case of uniform circular motion. So we know power equal to force into speed होता है. Power delivered, force into speed. So we are given here AC with central acceleration k square r t square, and hence and then v square by r central force acceleration. So it is k square r t square, to v square equal to k square r square t square, and hence v equal to k r t. This is the velocity at time t. This equation shows that velocity changes with time t. And if velocity changes, then there is acceleration. And if there is acceleration, there will be a net force. So how much is that force? So force acting on body, force acting on particle, which is producing change in velocity. Is given by F is equal to m dv over dt. But dv over dt, actually, it is acceleration. F is equal to ma, or m d upon dt of v. V we have determined is this k r t, and therefore F is equal to m k r. M k r is the force acting. K is constant, given r radius and mass, and therefore power delivered P equal to F into V m k r, और V हमारी कितना है k r t, and hence P equal to this m k square r square t. So we have to look into different type of questions. Every time we should remain in search of new idea. Actually, I was searching this type of question. If the body moves on circular path with a variable velocity, then how much is the work done and how is the power? But in case of uniform circular motion, you know very well, when particle moves circular path with constant speed, force is always at right angle to velocity, and hence no work is done, and power remains constant. No power delivered. Now I take another question here. These questions are from some book published by Nagin Prakashan. Then author Kumar Mittal Newton Physics, a good book. There are good collection of questions here. Now, yes, for sake of simplicity, I take a simple question here from the book. Here is a spring, a block, and connected to a spring. Mass of block is 980 gram. 980 gram. A bullet of mass 20 gram collide with this and get embedded into it. Now, the block is contact with the spring constant K, 100 Newton per meter. Now, 100 Newton per meter. After collision, the spring is compressed by 10 centimeter. X 10 centimeter compression in the length of spring. ठीक है भाई? So you are asked here. Number 1, velocity of block after collision. ये पूरा मास चलता है किसी स्पीड से, वो वेलोसिटी. एंड वेलोसिटी ऑफ मैग्नीट्यूड वेलोसिटी ऑफ बुलेट, ये यू भी कुछ है इसका. एंड देन लॉस ऑफ काइनेटिक एनर्जी ड्यूरिंग दिस कोलिजन. लॉस ऑफ काइनेटिक एनर्जी. तो हियर mass of bullet (0.020 kg). Mass of block 0.980 kg. So total mass of block and bullet is equal to 1 kg. So 1 kg mass is start moving as the moving bullet get embedded into it together, and this velocity, kinetic energy of block will be stored in the form of potential energy. Your kinetic energy of bullet and block system after collision is equal to the potential energy of compressed spring. Hence, half 1 into v square equal to half kx square. This half k is 100, x is 0.1 square. So 0.1 square cancel. So v square is equal to 1. So v is equal to 1 meter per second. Is the velocity of block and bullet after collision. ठीक है भाई? This is another question here. Now you are asked this velocity u. How to obtain this? ये कैसे मिलेगी भाई? By this collision between bullet and block is perfectly inelastic. After collision, so it is 0.020 u momentum up before collision, momentum after collision 1 into 1, so u is equal to, I will got my point, the momentum of bullet into its velocity is equal to m plus capital N into v. You have determined this v as 1, this is 1 kg I have written, so u is equal to 1 upon 0.02, it means 100 upon 2, 50 meter per second. In fact, these questions are meant for you, not for a teacher. But the students are in the habit of not applying brain. That's why I am solving. Now laws of kind energy. So kind energy of bullet before collision, half mv square 0.02 v50 square, it is 0.01 into 2500, so it is 25 joule. Now kind energy of block and bullet system, kind energy of block and bullet after collision. क्या होगी भाई वो? हाफ इंटू 1 और इंटू की वजह से 1 थी, तो 0.5 जूल, and therefore loss of kind energy in collision (25 minus 0.5) is equal to 24.5 joule. So large amount of energy is lost here in the form of heat. So I have solved these two questions here. We will be telling more questions in coming videos.